So today we're going to be taking a look at key lifecycle management, a brief overview of that in terms of enterprise key management, why it's important to have key policies and key attributes and key states as defined by NIST, and how they're going to be used in an enterprise key management environment. Talk about key rotation and re-encryption. It's one thing to be able to generate a new key, but you have to consider existing data. What do you do with that in terms of re-encrypting it? How much of a burden that's going to be on your organization, whether it's data at rest or column level encryption. And then it's one thing to have enterprise key management, but if you don't have any way to make it easy for a security operations team, there should be ways to automate that, rather using a REST API or command line. We'll take a look at some examples of that. And it's again important in terms of having separation of duty to reduce the probability of a breach, having more than one party involved with managing the key environment. And then we'll take a look at some best practices in terms of key management. So this slide is nothing new to any of us. As data is migrating out of the traditional environment where you have on-prem, some of us might be using tools like Veeam to do your backups in third-party storage areas. Data lakes like Snowflake have your external data. Obviously, your cloud service providers, whether it's Amazon, Google, or AWS. Right? We're losing this lack of visibility in terms of where our data is. There's no centralized control. And we obviously have a lot more attack services. So one way, obviously, of mitigating that risk is to encrypt your data, right? So, and there's a lot of different ways to encrypt your data. We're going to take a look at that. But you can't do encryption without encryption keys, which brings us to the enterprise key management. So each one of these different encryption providers, like storage systems, they have their own encryption methods and places to keep their keys. If you're using databases like Oracle, SQL Server, you can use TDE. Again, they have their own methods to keep those keys, but unfortunately they're kept in the database, right? It's not a best practice to keep those keys with the same place where the data is. You might even have some of your internal file systems or your applications using open source tools like GPG or whatever to encrypt your data. Cloud storage providers, we know, have default encryption, but is that default encryption going to be good enough for your different use cases, depending on how your data has been classified? So data lakes, already mentioned tools like Snowflake. So basically, in even virtual environments like VMware has the ability to have a key manager, but again, that key is going to be within that VM environment, right? So it's never best practice to have those keys with the data that it's protecting. So in 2021, Thales partnered with the Pullman Institute and did a study across global organizations. They said that a lot of organizations have up to 5 different key manager systems. So from a security operations perspective, that can really be a burden, right? There's no way to get consistency in terms of key rotation and whether or not those keys are being destroyed properly and being used by the appropriate persons at the right time. So what are the 4 pillars of enterprise key management? Centralized key storage. We'll talk more about what that means in just a bit. But NIST has some standards called FIPS, and you should, in terms of having an enterprise key management system, make sure it conforms to various FIPS levels. But it's not just about the storage, but it's also about the generation of those keys. They have strong seeds and strong random generators, so there's no way they could be potentially hacked into. Centralized key lifecycle management, again, we talked about having standards in place so that the keys are rotated once a year, once a quarter, whatever your security operations team has dictated is what the requirements are. And so we're going to talk more about that in just a bit. And a lot of customers obviously have data in the cloud, on-prem, so these enterprise key management systems should be clustered. So you get HA, they can never go down because your systems will be down if they can't decrypt the data. So it's important to be able to have support for both cloud and on-premise. And then the other important pillar of enterprise key management is the ability to conform to various standards. PKCS 11 is one, and KMIP is an example of another. So I mentioned NIST. They have recommendations for key management. I'm not going to go into details on it, but I would recommend you to visit that site if you want more information. But they have guidelines for how to implement proper key management systems. And one of the things they recommend here is to put together what's called a cryptographic key management system, right? And so basically what that is It's a document that will define what your security policy is in terms of your key management architecture. So it'll describe your objectives, the constraints that apply to both generation of the key, the accounting, who's using those keys and when they're being used, and whether or not they're being destroyed appropriately upon you bring your system down and offline. So the other thing is you should also have the appropriate crypto mechanisms, right? Hopefully you're not using DES anywhere in your organization, but if you're using AES, you're using the strongest key length, which is 256. Same thing with asymmetric key encryption as well. And then lastly, one of the things they talk about are some of the goals and responsibilities from a management perspective. Having proper separation of duty, having different organizations be responsible for doing different things. You don't want your DBAs being able to create a key. They should be going to the security operations team person who will be responsible for doing that. And then have a separate person for auditing as well. So, which brings us to, do you know where your keys are and are they safe? Well, that's one of the purposes of an enterprise key manager. So, as I mentioned before, FIPS is a common standard produced by NIST, and they have different levels. So 140-2 and the various levels. Level 1 is typically can be satisfied with virtual equipment. Doesn't necessarily have to be hardware. There is more verbiage on this too. If you're interested, you can visit the NIST site. Level 2 is typically a hardware appliance and it has tamper evidence built into it. And it also has to conform to common criteria. Level 3 is typically even level 2 requirements, and then also has some additional physical tampering resistance. And it also typically will be backed by what's called an HSM, hardware security module. So, and also, if you notice there that private keys can only enter or leave in an encrypted form. I haven't seen anything at level 4 yet, but it is available apparently. And then also NIST is now coming out with 140-3, so this is constantly changing. In order to get FIPS certified, it's a very rigorous process and takes a lot of time for organizations to get certified, so it takes years and years. So let's talk more about encryption keys, because there are different kinds. At the lowest level here are secrets, or what's called data encryption keys. These are the keys that actually encrypt your plain text, your database files, or whatever. And then above that are domain keys. So your enterprise key manager can be structured with domains. So you may have an HR department, finance department, and those different domains are where those keys are kept. And so you start building this hierarchy, so then you basically have key encryption keys wrapping those lower encryption keys. And then finally you have what's called a master key. And this will become more important too when we start talking about re-encryption and what has to happen. As well. And finally, what you can have if you want that FIPS level 3 certification, you do have to have an HSM involved somewhere in the picture, and that is a separate device which will then encrypt the master key. So it is a hierarchy there, but again, this is important to understand when we talk more about re-encryption. So when it comes to compliance, all of us are very familiar and aware of all the different compliances, whether it's HIPAA, PCI, SHREMS or whatever, GDPR. This is just an example of PCI, what they require or what they would like to see from a key management perspective, like requirement 3.5 says keys must be kept in a secure device. If you're going to be PCI compliant, key rotation must be part of your lifecycle management. Key custodian roles. I have different people who have different roles in the organization, and they're responsible for doing different things with those keys, right? So it's important to understand it from a compliance perspective as well. And then finally, they also recommend one of the requirements, 3.3 and 3.4, that if you can afford to do so, do column level encryption. So on the right-hand side there, you can see there is different kinds of encryption. And this is in the context of a cloud, because you're bringing your own encryption. But you can have scenarios where you basically have EC2 instances. In the case of Amazon, you install an agent on it, and then you define where your sensitive data is, and then you can just basically protect all those unstructured files. It doesn't matter what kind of file it is, but you're basically encrypting all of that data in that directory. And then to the right there, basically, this is a use case or scenario where you might want to protect a column in a database or a field in a file. So this is much more complex because it does involve code, but it is appropriate for different use cases. So, and that's what is meant here by column level or field level encryption. Another compliance is SREMS. And again, this is in the context of a cloud. So cloud service providers do provide their own level of encryption, right? So, but it's implicit encryption. You're really relying on them for both the keys and the encryption. But they also allow you to do things like bring your own key, right? So in that use case, you create your key in this enterprise key manager, and then you push it to the Azure Vault, you push it to the AWS KMS, or you push it to the Google Key Ring. So you're the owner of that key material, right? But they still control the encryption. But that does give you some control over, backing up that key and things like that. So you have more control over, if you want to, for whatever reason, limit that key to just certain use during the day, you have the ability to do that sort of thing. And finally, what happens for SREMS in that particular case, you might want to consider, depending on how the data is classified, to both bring your own encryption to the cloud provider. In that use case, you own the keys and you own the encryption both. So it gives you much more control over doing things like re-encryption. So there's an independent organization called the Cloud Security Alliance. One of the things that they like to say is that keys should never be just stored in the cloud, but they should be provided by the consumer or the trusted key management provider. So just another independent organization that talks about enterprise key management. And then each cloud service provider also recommends that for your data, the responsibility is always retained by you, the customer. So whether it's a SaaS environment, platform as a service, or infrastructure as a service, that the encryption and the encryption keys are really your responsibility. So what are the options for encrypting in the cloud? Again, you can bring your own key, and this is provided by an external key manager, and then, or you can have use cases where it's hold your own key. In that particular use case, it's a key encryption key that's, but it's encrypting the data encryption key, and here's some examples there. Amazon's called XKS, Google's called EKMS, Microsoft has double key encryption. The Amazon one was recently released. Basically, what's going to happen is in that particular use case, anytime a call to encrypt or decrypt data, it will reach out to the external key manager to decrypt the data encryption key. So again, it gives you more control over the keys in the key life cycle. And finally, again, we talked about bring your own encryption. That's the use case where you own the encryption and the key itself. So when we talk about enterprise key management and cloud, again, the external enterprise key manager gives you more control. It can support infrastructure as a service, platform as a service, and software as a service. It gives you the compliance from a FIPS certified appliance. You're going to get common, consistent reporting across all the cloud key providers, whether it's Google, Salesforce, Amazon, or Azure. And then you get the more control over rotation, deletion, and expiration of the keys. And again, you've got disaster recovery and authorization controls built into the system as well. So the cloud service providers do allow you to just use an HSM, create the key, write a script, upload it. But it doesn't really, if you do that method, you got to write the script. You got to figure out how to maintain it. And then basically it's very error prone because again, you're maintaining a separate script. And it doesn't do the backups. It doesn't do the auto deploy, monitoring, rotation, auto expiration, and things like that. So an enterprise key manager will obviously do everything on the left-hand side there that you don't have to maintain the system, external system code that you have to write in order to do it yourself. Again, this is just looking at an external key manager. Can handle all the various use cases. We talked about, today maybe your DBAs are using TDE, but again, those keys are in the database. You can have them Change the configuration so that the keys are actually stored in the key manager. We talked about different cloud providers. You can either bring your own key or hold your own key, depending on the cloud service provider. You might have some homegrown systems that are already using GPG or whatever, or some of the industry standard protocols, such as PKCS 11. And then a lot of the storage vendors on the right-hand side there also provide a KMIP server, KMIP client, which talks to the key manager over that protocol, another industry standard. And this is just an example of what an onboard versus an external enterprise key manager would look like. So basically, as I mentioned before, they do provide an onboard key manager. Some of the vendors do, but you typically are going to get FIPS level 1. You're not going to be able to support a heterogeneous environment, whether it's cloud. You're basically supporting that particular device alone. You don't get the separation of duties because the same person installs the hardware is going to also own the encryption as well. And then in terms of high availability, they don't really support clustering for key management. So in summary, why use a key manager? We talked about secured key storage in terms of FIPS compliance. We talked about the ability to support multiple clouds, central place where you can go for all your keys. You're not hunting, pecking around the systems looking for keys in the file systems. You can set up roles, and we'll talk more about that in just a bit. And key managers do adhere to the industry standards. The developer-friendly APIs, we'll talk more about that in just a bit. And then you get the auditing and monitoring. You can send all of the audits over to your favorite SIM tool. So what are key policies and attributes? So key policies are a way to get consistent, when you create a key, to get consistent behavior across a particular user, across a particular group, or a client. A client is anything that's going to connect to the key manager in order to get the key, in order to do any sort of encryption or decryption. So here's just an example. For instance, for this particular key, I might only want to have my admins be able to read it and export it, right? But you can see there that there are other attributes: decrypt, encrypt, sign, verify. You'll never get this with just if you create your own key, you can open SSL or whatever on the file system, right? So key managers give the ability to write these more detailed key access policies. And here are some examples of key attributes. Every key can have a specific attribute. From a usage perspective, I might want to create this key only for sign, verify, maybe just encrypt or decrypt, or format on the far right-hand side, format, preserve, encryption, or decryption. And of course, you have all the different dates here that associate to key states as well, which is we'll talk about next. So this is what the NIST recommends for key management in terms of states. Active means that it can be used for encryption, decryption. Pre-active, I can create the key, but it's not ready to be used yet, so it's usually tied to a date. So when that date hits, it'll automatically become active and used for a particular system. We talk about key destroyed. It means it can't be used for any encryption, decryption. But if it's in a state of deactivated, that means it can be used for decryption, but not encryption. So it comes into play when we talk about version keys in just a bit. And this is just a state diagram that NIST provides. I'm not going to go through it, but just keep in mind that any sort of key manager should adhere to the state diagram. So when we talk about key rotation and re-encryption, again, this is a slide I showed before, but some of the scenarios or use cases, depending on your security requirements, it becomes very difficult if you're going to go ahead and create a new data encryption key, because that does involve having to re-encrypt the data. But some security ops teams or security auditors will let you get by what's called a shallow encryption, which means you can just encrypt the master key and therefore don't have to re-encrypt the data, because keep in mind that's a key encryption key. So depending on which your auditor considers valid, you might want to start out with that as a policy, unless you have super, super sensitive data, then it probably does make more sense to go through, generate a new key, and then re-encrypt your data. So when we talk about key rotation, it's really important to understand, well, how long, what's a good policy? What criteria should I use to determine how long a key should be in use? So some of the things you can consider is that, basically the greater the key is in use, the higher probability that it's going to be compromised, right? So you might want to take a look at the value of the protected data, how it's classified, the volume of data, or the frequency of use, as well as some other criteria that can be used to determine how long should this key be valid for. Here's a little bit more detail. If you're not happy with just those three things, like if you have somebody in the security department and they've since left the organization, you might want to consider a use case where you're going to re-encrypt the data sooner. The volume of transactions or the amount of data that's involved. You might want to also consider that as a criteria for doing it more frequently. The security crypto mechanism, right? If you're only using AES 128, then you might want to consider use cases to re-encrypt the data sooner. And this is just some examples. Everybody's always asking, how often should I be re-encrypting my data or generating a new key? So depending on, again, if you have a symmetric key for authorization, they say up to 2 years. And this is just an example of what you could use. But, some organizations might want to do it every 3 months, every 6 months. Again, you have to take a look at, generating a new key means you have to re-encrypt the data. So, or, again, we talked about just re-encrypting the master key, right? And then you don't have to re-encrypt your data. So what does a version key look like? So on the left-hand side, basically you have some metadata, the key name, the algorithm, the key size. That won't change every time I generate a new version. The only thing that really changes is the key material and the initialization vector and the state, right? So we talked about, use cases for version 1, will always be able to use for encrypt and decrypt. Version 2, which is the non-current one, you still might have data out there using the older version, so you still want to have that key be able to decrypt your sensitive data. So that's one method from enterprise key management. A lot of them do support version keys. If they don't, you always can just go ahead and create a new replacement key. And then the problem with that is you do have to re-encrypt your data. And this is another example of what key versions look like. It might be kind of hard to read, but you can see the key name is the same. On the second column is the actual version. And typically what you do is have an alias. And every time you use the key name, it references the most recent one. Then specifically, if you need to access a version key, there's some syntax changes that are involved with that. So when we talk about re-encrypting the data, it's important to understand the different kinds of encryption that's out there in the market. So at the lower level, you can have encryption work at the operating system level, and that's what we call transparent encryption. Again, that's basically encrypting a directory or any file on the system. And then if you move up the stack here, some database vendors like Oracle and SQL Server provide TDE. If it's SQL Server, they also provide column level encryption. And then again, moving up the stack, some organizations just want field level encryption, only going to decrypt the data using some application code, right? Much more difficult to implement, but you do get more secure environment with that. So when it comes time to generate a new key and re-encrypting the data, for data at rest, there's two different methods. For non-versioned keys, basically what you have to do is bring your database down or your file systems down, decrypt the data with the current key, and then re-encrypt it with the new key. Some key managers support the ability to have version keys, and then basically what you would do is automatically rotate the key, and then you have a schedule so that determine when the system should re-encrypt the data, and then it does it behind the scenes with no downtime. So obviously, option 2 is more preferred, but not every enterprise key manager supports that capability. And then finally, the scenario where we have field level or column level data. If we're talking about use cases, option 1 is where you're going to track the key version, right? You can either append that to the header of the ciphertext, or you can store that key version in another column in the database, right? But if you do that, your records are going to be all your data that's encrypted in those database files, or the database or the flat files, will have different key versions. So it's more of a maintenance hassle to deal with that use case, my opinion. Option 2 is to re-encrypt the data with non-version keys. You do need to export it and then do the bulk update operation. It's kind of a busy screen, but it's again just showing you what a version key would look like. At the top there, the dark 3-4 number. You can see there it's 13 bytes originally, and then the version will have 3 bytes. The 10.0010 represents the version of that key, which does expand it. So if you're using, format preserve encryption, your fields will have to be expanded by 3 bytes. So that's something to be considered. But down below, if you have the option, you can also store that version in another column, right? So your original database field doesn't have to change, but you do need to find another place in your table to store that version of the key. And so how would you go about transforming this data that has a use case where you're going to generate a new key, right? So basically you would export from your database all your data that has the old, it's been encrypted with the original key, and then you would use a utility to go through and detokenize it, and then go ahead and then use the new key to re-tokenize it or re-encrypt it, either or. So, and then re-import it into your database. So it is time-consuming, as you can see. There are ways to go directly from SQL to SQL, but typically the database vendors have their own load tools, which are typically the fastest. So what are some of the operational considerations? One thing you might want to consider is using like a REST API to automate as much as you can. If you do that, make sure that you've limited usage of that API to just certain functions, so they can't be used for everything. There's no reason, if you're going to enable a separate account, to have them have to log on, for instance, the key manager system itself. So this is just another example too from a command line perspective. You can automate a lot of the tasks in terms of, here we're going through and we're generating 10 keys with a specific label on them, so you can easily query these keys later. And then you can do a lot of things like list the keys by label. You can query, I want to find all my keys that are going to expire, certificates that are going to expire, and that sort of thing. So we talk about reducing risk in terms of the environment. You can set up what's called separate domains, right? So domains are just a way for you to isolate your keys and provide different administrators of those keys, right? So you can do it by like business units, typical domain. You can have a domain by application or domain by security. You got PCI environments, non-PCI, just an example. Again, so it's another way for you to have separation of duty, because you can have different individuals control those different domains which have those keys in it. And this is just an example of like a use case where maybe a DBA needs a key and talks about separation of duty. They wouldn't be responsible for creating the key. They would go out and ask the security operations person they have a need for a key. They would sign on to the key manager, create it. Then all the policies and procedures would kick into play in terms of when the key is going to be rotated, and make sure it conforms to different key properties, who can access that key. That person would then push it to the Azure Key Vault, which would then make it available to the DBA to use to protect his database. And then again, the key is stored and backed up in a FIPS certified appliance. And then you have a separate person involved with using the key manager to do auditing and make sure that it conforms to the security department's requirements. So some best practices in terms of enterprise key management. When you create and store keys, they should really be separate from use. We've already talked about that. Key manager should be a separate role, both from your organizational perspective. and then also from a technical implementation. One thing Google is constantly told Thales as an organization that one of the number one blocker to the customers migrating to their workloads to GCP are the encryption and key management concerns. So that's why we have a very close partnership with Google and support them in terms of having an external key manager for hold your own key use cases. So when it comes to cryptographic keys themselves, you might want to set forth some policies and procedures so that they're consistent in naming. For an example, you could have a division, application type, and then usage, e-commerce, payments, AES is a type of key, and then usage is format, preserve, encryption. And use key labels. It makes it very easy to query keys. Like I want to find all my keys in the HR department that have a 360-day rotation policy, that sort of thing. So again, for key scheduling, it's important to have those keys rotate in a particular schedule, and you can go ahead and use labels, for instance, to make sure that all my HR keys are going to rotate every 360 days. You don't want to have all your rotation happen at once because it's a burden on the system. So having labels with separate dates is important as well. So in terms of rotation policy, again, we already talked about longer keys in use, the greater chance of it being compromised. So you might want to look at a policy that works for your organization, right? You don't want to have it be an administrative burden to your security operations team. So again, if you can get by with just rotating the master key and it satisfies your security requirements and the data's been appropriately classified, then that might be the best method. But again, it's important to look at not only from a security perspective, but an operational perspective in terms of key rotation and re-encryption. So IDC is an independent, is a consultant organization that also talks about encryption and centralized key management. And one of the things they talk about is having the ability to build a robust key management infrastructure, and that your key management environment should be flexible, and also have proper access controls and include the appropriate data encryption as well. So, and that's in summary. So basically, I do have a couple resource links if you're interested in learning more about key rotation, key management. There's a couple of people in the back room that also work for Thales. So if you're interested in learning more about us and our capabilities, please feel free to talk to them as well. So, yeah, but.
Any questions?
I mean, it might be a bit of a loaded question, but I'm just curious what your thoughts are around like the whole quantum thing. And
Yeah.
you may not be able to just decrypt things now, right? But we can collect it and then.
Right. Yeah, good question. So, yeah, there are organizations like Wells Fargo that have today a department for like 40 people doing post-quantum computing, and they're setting up labs and trying to get ready for that. The whole question is when. I do have a couple slides that we could kind of go through if you want, but it is a good question because the whole subject of quantum computing is an interesting one because it's all about when, right? We all knew when Y2K hit, but we really don't know when quantum will be pervasive, right? But when we talk about quantum, there are really three pillars to having a safe quantum environment: the ability to generate keys with provable, unpredictable keys from quantum computers, key algorithms. NIST is in the process of coming up with some algorithms, new algorithms, and then key management, being able to, again, have tamper-proof lifecycle management. But the quantum, quantum will break today's encryption, right? So we're talking about PKI environments, and if PKI breaks, then pretty much everything breaks. So NIST did have first round of algorithm submissions, like 26, but then since then they've opened up to 40 more, and they have different phases. So from what I understand, Falcon, Sphinx, and Dilithium are some of the algorithms that are available today, like Key Factor, I don't know if you're familiar with them, but they have bouncy KSL libraries you can download today that support that. They're in beta format, but the whole idea is then you got to think about the certificates and things like that, because today all of our applications are still built to only handle the classic public keys, right? So when we talk about quantum computing, everything changes. And again, we talk about time frames. This is sort of gives you an idea of what the industry is thinking in terms of, we got 1 to 5 years in terms of what's the likelihood that quantum will be pervasive in 1 to 5 years. Pretty low, but again, the risk is medium, so maybe there's 1 or 2 quantum computers out there, but they're really owned by Amazon and IBM, right, and who has access to those. And then medium term, 5 to 10 years, again, now likelihood is medium, and the risk is high, right? And then long term, 10 to 20 years, we better be ready. And so what can you do today? Basically, this is a slide that shows, again, the Pullman Institute did a study that 72% of the population polled thinks within 5 years, we're going to have some impact of quantum computing. And today, one of the best ways you can start preparing, according to this Dr. Lamachia, where, we need to start building our own labs and getting familiar with this, right? And we as vendors, corporations should be pushing their vendors to have answers to quantum. So one of the big new buzzwords is crypto agility, and basically it's allowing you or vendors to create equipment or algorithms that will not lock them in, right? So you're not confined to, once you implement this, you're stuck, right? So crypto agility is to be able to quickly shift or change your algorithms to a more secure one or more standard one once the standards become available. So that's one of the recommendations they talk about. And one of the things NIST is doing is talking about this hybrid approach when it comes to certificates as well. But there's going to be quantum random generators and these new algorithms. But again, when it comes to certificates, there's a couple different methods to do it. One of them is you can have multiple certificates. That's never a good idea. Or you can have what's called a hybrid, which the certificate will include both the classic public key and as well as the quantum public key as well. And they basically shove it into an extension. Or you can have concatenated ones as well, where they basically take the classic public key and then the quantum one, concatenate them together, but then all the applications will have the intelligence, and the algorithms will have the intelligence to know how to parse it. So that's where there's a lot of change that needs to happen in order to make that happen. But so I would encourage you today to push your vendors and to start looking at getting some more familiarization with post-quantum, because there's ways to do it. So.
Question about HSMs.
Mm-hmm.
So we started looking at the idea of utilizing them.
Mm-hmm.
And we're seeing that there are cloud-hosted options for HSMs.
Correct.
But I know you mentioned earlier that CSA says they shouldn't just be storing in the cloud.
Right.
So I guess what are your thoughts on that? How to maintain that balance?
Yeah, good question. So yeah, you can get FIPS level 3 certified by having a cloud HSM. But really what that protects you is there's a security enclave within the hardware itself where those keys cannot leave or can't be tampered with, right? So that's the part that FIPS certifies, is that component there. So it is technically possible to have a non-hardware on-prem and still get certified. So yeah, it's basically the way it works. Yeah. So, yeah, so basically for Amazon, right, it really depends on if you're doing cloud storage or you're doing EBS storage systems. With EBS, it's an EC2 instance, and you can have more flexibility. You can install agents on those platforms and bring your own encryption. But if it's not, if it's an S3 bucket or whatever, there are ways to protect that too with external systems to bring your own encryption. Or you can also rely on, for instance, the facilities that they provide. And then that's where you can bring your own key. You still own the key material, but you have more control over it. You push it to the KMS, and you would protect the S3 bucket with that key in the KMS. But it didn't originate at Google. You've got it stored in a separate device. So you own the key material. So it really depends on use case too. Like if you're using DynaDB, right, you're talking, you have to use field level encryption. So you would encrypt it at the ingest level when you load it. But then the application that needs to decrypt will have to use code to decrypt it. Same thing with Redshift. So like Amazon Redshift, you can write external UDFs, user-defined functions, which can invoke external tokenization or decryption as well. So they do provide that facility. But again, RDS doesn't. So it really depends on the service. So.
And once you do that, you have to decrypt your data and manage it.
Yeah. So basically, if you want to generate a new key, then you're right. You would have to, decrypt the data and then encrypt it.
Is there a way to come up with a ballpark figure of how long the process is?
Really depends on the number of records and the number of columns that are encrypted. So, yeah. Yep.
So if we shift this down to the cloud, how does the separation of duties component work? Right now we have just a separation of duties, different teams, different key holders, et cetera, or key signing and so on.
Mm-hmm.
In a regulated environment,
Mm-hmm.
how would you certify the separation of duties from a security policy?
So basically, like with the key manager, what you can do is you can have different roles for different individuals. Like I only have this group or this person have the ability to encrypt or decrypt or just create the key. That's all they can do, right? So when they log on to the key manager system, there's only certain things they can do based on who they are.
So we would still use our own staff and just remotely.
Correct.
Unlock.
Yep.
So is that something that is available as a cloud provider where they can have that staff to do, to make it truly a shifted responsibility to a cloud provider?
Yeah, I haven't seen that. We as an organization will have a service for our external key manager as well. So there might be some movement toward that, but right now it's pretty much at the customer's control to be able to do all that.
Cloud services are really just shifting the hardware out there.
Correct.
The roles and responsibilities.
Correct.
Thank you.
Yep.
There are no further questions.
Yeah, thank you. Yep.
I'd like to offer you a certificate
Oh, thank you.
for our gratitude.
Appreciate it.
Thank you very much.
Sure.